Hello, it's Greg, and in this video I would like to focus on the development side of the reader, because you will download the repo, and then what's next. And to find out how those things are working, you should at first try to understand how the IFC5 file is constructed. And the IFC5 at that point is a JSON file, which is just an array of different objects. But those objects, they reflect a different parts of constructing, of composing your IFC model. So they can be the class. And as you can see, there is the discriminator type here. So based on that property, we will be able to assume that, okay, so this is the class, this is the def, and somewhere at the bottom there are the overs. And probably you are now thinking, okay, so what's the difference between the def, over, and class? And I will not try to answer that question because it is really nicely described by Leon and his curse. Here it is. So there is one module here, def, class, over, in that USD terminology chapter. So here you can just, let's see, just open that video and see quite a lot of differences and how they all are composed when you are reading the IFC5 file. So please go to Leon and hear his answer about those differences. I will just try to show you from the .NET perspective how that reader is working, because that's my main focus in that material. So as you saw, this IFC is just the array of objects, but they are different. Their structure is different. So it's just a play of the same class. But here we are dealing with some children, with some inherits, with some attributes, and it all makes our life a little harder. So I decided to not try to use the built-in JSON deserializer, but to write my own settings for the newtons of JSON. And it can be found in the models, and here is the deserializer. So I'm just using newtons of JSON, but with my own converter. And why it is needed? Because based on those, based on the value of that def property, I am assuming that, okay, so if that def is the def, then I want to initiate the class def.json. If it is the class, then you get the point. And based on that, I am able to move the deserializer coming from the newtons of JSON into the proper track. And it could be done with some magic attributes and all of that stuff, but I just wanted to have it very clearly in the code. And then there is also one more thing which is different. Those are the attributes. And I think that the better name would be the components, because attributes is quite too generic for my sake, but okay. So those attributes are some things which are coming from the information in the PIM. So the class of the object, the fire resistance, the material grade, all of that stuff, it can be added as an attribute, or the geometry itself, the transformation of the local coordination system. It all can be in the attributes. So that is the most capable property in that schema. So you can put in that bag almost everything, because at that point we don't have the clear rules what can be then there. And in that JSON you can always put some random stuff. But if you are interested in the schema itself, then you can go to the repo, the official one, and then there's the schema directory, and there is the type spec. But reading the type spec, maybe it will help you to better understand. But for me, more verbose was this already generated TypeScript, and it was here. So it very clearly says, okay, so what does it mean to be a class JSON? What properties do you have? And those files, they can also be found in a plain JavaScript. So for example, the class is here. So if you, depends on on your needs, you can find it here or in a TypeScript form, but please be aware that they will definitely change, because there are some misalignments, some things which needs to be polished before truly releasing. We are still working in the pre-alpha version of the IFC5, so hey, don't build your best startup on top of that, because it will definitely change a lot. But let's try to see what are the advantages. So here is the schema. I have just grabbed it and attached with some attributes. So then with the help of the Newtons or JSON, I'm just deserializing those properties. And to make it more clear, I have created one very dummy test. It's just about the reading, but okay, you will see it here. So let's go here and let's see what will be the result of the deserialization. So here I'm just providing the path to the IFC5 file. It is read, and then I am getting the content. And let's try to see what we are getting here. So here we are getting 69 objects, which are just coming from that array. So if you count those top level objects, it will be the 69, and the first one was null because, yeah, I just skipped this disclaimer. I'm not sure how it should be. Will it be there or not? Yeah, that's why the first element is null. But then we are getting some class, and let's see what's here. So that class, I will just move a little here. So this is that one. And its name, the name, it makes some problem later in when we will be thinking about the children, because if you look here, we have the attribute children, and here we have the array, and the name of the children is void, and that is the body. And later in that file, you will find quite a lot of different bodies. So yeah, there are 6 of them. And that's why when I am composing those children, then I am saying that, okay, so the children is coming from that parent, so I'm getting that name and making some separator like this. I think it is, yeah, just grabbed from the sample from the Building Smart. So that's the convention how I am tackling with those children. But okay, here the first object is that thing. It is the form of USD Geom X form, and it has 2 children. So let's look, and those are here. So they don't have the children, they don't have the component, but they inherit something. So this is this concept. And very often in that file, you will find cases when some dev will inherit some class. So here is that class, and that class at the very first point, it looks empty. It doesn't have any attributes, any more inherits. It's just some placeholder. But later, if you will try to digest into that file, you will find some overs which are adding new data into that. And that's the main concept, in my opinion, behind the IFC5, this granular composition, that you don't need to specify at the very beginning all information about that mesh. You're just saying, hey, there will be some mesh, but how exactly it will look, where it will reside, it doesn't matter at that point when you are just creating the file. Of course, when you will try to view, to compose the IFC, then you need to have those information, but they can come from a different source, from a different representation. And that's the main shiny thing in the IFC5, that it assumes at the very beginning, in the terms of how the file is composed, how the schema is composed, that, hey, there is no one in the industry who knows everything about our construction. That our AEC sector is coming from a collaboration from multiple parties. So they all have to say something about that particular wall, column, road, whatever. And, you know, it's so obvious for anyone who is inside of that industry that, you know, the single IFC, who should create it? Who should maintain it? How? So we are too spread, I would say, and the constructing of the building is quite a complex task in terms of humanity. So that's why you will have to deal somehow with that composition. But yeah, the composition is part of this composer. So let's dive deep into here. So what is going there? There are 3 main classes which are used for the composition. So the first, as you remember, we are just getting some preams. And here they are. Yeah, it's just the enumerable. So let's cast it to the list. And why? I don't have the system link you. Okay, but yeah, those preams is the list of all of those entities. And now I want to flatten them. I want to make all of those children to the top, because as you saw, we had some children and they are related to some other entities. And at the first point, when you are just watching on that single object, you don't know what is the graph, what are the relations later? Okay, so that def, it inherits with from some class, but what about that class? At that point, you don't know. So my proposition is to at first unflatten all of those data, but preserve this relationship. So somewhere in some dictionary, we have to write that, okay, that parent, it has two children. So that is what is going under the hood here. So that flattened tree is a list of all of those prims, all of them. So at the very beginning, we had 69 entities, and there were just the top ones, but now we have 91. And if you would count all of those objects, which are also some kind of a prim, so they are def, class, or over, you would count 91 of them. So they are coming from here. And as you can see, those are, for example, the children. As I said, they have those double underlines between the parent name and the child name. So we have a very big, maybe not very big, but you know, we have just increased the number of objects. So we don't have the tree, but we also have the relation. So we knew what is the parent and what is the children of those entities. So for example, this one and 25.5 something something. So this is this one. This is this key, and it had two children. That one and that one and that one, because there are two underlines. So, and later, if we will try to see, okay, so what about that? Then we will see that it inherits from some other entity, from some other prim. So those relations about the inherits, they are also converted to the parent-child relation. So they are somewhere at the bottom. They are done later. And with those two things, so the flattened list of all of those prims and the relations between them, we are ready to make the graph. And yeah, it can be done in any way, in some for each loop, in some, like I have done with a depth first search algorithm, or with the pref, so the B at the very beginning. It all depends on your needs. Now we are just dealing with a very small graphs, so it's very hard to say anything about the performance, because we have only 91 nodes, so nothing too hard. But okay, here there is the graph composition, and after that we will get not the flattened tree, but the true tree. So now we know that there are 4 roots, 4 elements which doesn't have the parent, which are the first. And if we go later top down, then we will see that, okay, this project has 1 children, this is here, and it has next children, and it has and you can do it quite a long time, because all of that is coming into the form of some tree. And here we see that my story, it has 2 children, MySpace and wall. And it's very hard to check, okay, is it working correctly or not? So there is one good thing coming from that course, and it's here. So this is the big graph of those objects coming from Leon from Buildings part. So here you can see, you can check your algorithm, how you are composing the tree. So we see that my project was a root, and then there was something which was my site, something which was my building, something which was my story, and here we have this distinction that my story, it has two children, MySpace and wall, and that's definitely that point of our composition. So this is here. And there is one problem with that graph, that it's not showing all of those prims, because here that my site is, as far as I remember, it is a def. So let's see where it is. So let's try to find my site. Yeah, this is this def. So, but it was the children, so maybe that's why Leon used the subprim naming here too, because it doesn't have the unique naming. It doesn't have this quite long unique identifier. It just has that my site. But the question is how we will be composing them. It is an open question. For me, I am just treating it as an standalone node. And so in my graph, that my site is also some box, but not with the class, but with the def. So now we are getting that tree, and it's quite a big one, because as you can compare, this is also the same tree, but with much better for the human representation than just a dictionary of parent children. So that is something what we currently have in the memory. But how to compose those objects, how to view them in some viewer? Then we have to go back into the difference between the class, def, and over. And we will see that if something is just a class, it is not represented directly in a viewer. Only the defs are something physical, but yeah, it's not the best word to say that they are something physical, because if we are thinking about something physical, then yeah, we are just thinking about something which we can touch. But maybe another word, the defs are something which has to be visible in a tree of your IFC. The classes are not there. So that's why in that sample is a very nice case of the window coming from some manufacturer, and you are using it in two different places. So that wall, it has two windows, but they both have the same geometry, they both have the same properties. But of course the transformation is a little different. So that is here. But okay, the problem with that our current root is that it also has the classes. So it has more than is needed for viewing it in some kind of viewer. So that's why there is a third step in this reader. There is the defs composer, and the defs composer, if we will go into that, then we will see that, yeah, that's just the constructor. So let's, yeah, here I am not very proud of that, because this is just a big iterative way to, recursive way to go through all of those children and try to compose bank from top to the bottom, and try to flatten the properties of the class. So here is the concept that, okay, the class is not something which should be visible, but the def, if it is inheriting from the class, like in the place of that window. So we had, here is the def, it inherits from some class, and that class inherits from some other class. But we only want to see that window and then the next defs. So that's why those properties, those attributes coming from the child classes, they are propagated to the parent, which will be the def. It's quite strange, I would say, because we had that portion when we had, here, we created the graph, the whole graph of defs and classes. But then we are just flattening, but only the classes. So that's why that's something which I think that it should be rethink in terms of that code. But yeah, at that point of time, it is working, and in such a small scale, it doesn't, create a headache that you are twice traverse through that tree. It should be done once, but yeah, at the term when we are composing the tree, I mainly focus on just implementing the depth first search composition. So yeah, that's why we have also that thing. And let's jump over. So here we are getting, as we had previously, 4 elements, 4 roots, but now they are not just a dictionary of parent and child, but here we are getting something which can be then rendered, which can be shown in some kind of a viewer. So here we are getting some components like those IFC classes, custom data, and their children. So at some point, one of those children will have my story, maybe, yeah, my story. No, it has 2 children. So my story, MySpace, and I think that MySpace, it has the component about the transformation. So that is something which will be needed for the geometry. Also the material binding to know how it should be displayed. And what is the most important, that one of those children, the body itself, it has the component, the USD GeoMesh component. And here we are getting the indices of the faces, and of course the most interesting, the points of those vertices. So this is the nature of the composition, that you have to somehow figure out how the tree is constructed, and later you are going from top to bottom to see that, okay, I have the project, site, building, whatever order, and later I have my wall with 2 windows. So that's what will happen next. But of course, not in the reader, because reader is just parsing, deserializing the JSON, and then composing those elements which are ready to display somewhere. And in my case, that somewhere is, of course, it is not the unit test, but it's the Rhino. So here, if we will go into the plugin, then yeah, it's quite straightforward. Yeah, developing with Rhino is always a pleasure, so let's just try to see where it is. IFC inserter, this is the first point, so here, this is the place when the Rhino will hit when you will provide a new file. So let's import the sample file, here it is. And yeah, here we are now in the IFC5 import plugin for the Rhino itself. So there is the separate class responsible for the insertion. And then I'm at the very beginning just reading the materials. And that is some concept which, yeah, because we had 4 roots. We had my site, my project, whatever what was that name. And also we had 3 later materials, the space material, the window material, and the wall material. So now I'm just reading them from the treating them as a root. I'm not sure that they will inherit or will the current concept will stay. But then I am trying to compose those objects. But of course, not every object has the geometry. So later inside of that, we have to check that our component, that our prim, sorry, that is the better naming, our dev, does it have the mesh which should be set as a visible, because there are also some invisible meshes. So I am checking just the existence of component. And if we have some USD geo mesh component, then okay, it's something which has to be displayed in Rhino. So all of the all of those nodes in the tree, they are iteratively processed, and yeah, some transformations, some colors, all of that stuff is happening in the background. But at the end, we are just getting those elements with a layer structure. And that layer structure is very dummy, but it's just to show you that, okay, if you will select the wall of the body, then you will get that object. So it's here, yeah. And if you are interested in the body of window, then it's here. So that's that. Okay. So that is the main thing, and as I said, the Rhino part is smaller one. It's just to make that visualization happening. The main stuff is related to the reading, the JSON, which in terms of the structure, it needs some polishing, but okay, it's quite a nice base. We have something, and then trying to compose your tree of elements. So what does it mean that that side inherits from that entity, from that prim, where it resides? So you have to somehow figure out the connections between those nodes, and later, based on those connections, based on that big tree of elements, you need to decide, okay, so does this my space, does it need any mesh? Does it need any representation, or is just the holder of some information? That's what you have to do in terms of your viewer application. But the reader part is quite agnostic, because yeah, as you can see, those are different projects. So the reader itself is just a class library which you can use and yeah, try with your best tool for visualization of the geometry, because that geometry, USD geomesh, I'm not sure what was the name. Yeah, that was that. So those they are just, let's see where it is. Where is it? Over here it is. So those are just faces, not triangles, because yeah, there is one. It's not well documented, but there is one entity which has just, yeah. Here we have something which has the vertex count set to 4. So that's not, yeah, the triangle itself. The rest rather are, I think. So yeah, but there is this one property which is not in the schema itself, but it's quite valuable in terms of parsing the geometry. So yeah, just a note. But yeah, in general, you can try on your own. There will be always that test. If you have some time, you can always write more of them, because that composition, as I said, it is divided into 3 different phases. So at first we are trying to flatten those relations between the children and inherits. Later we are composing the whole tree based on the flat nodes and relations between them. And that's my main, I think, maybe not. Yeah, that is something which make some things trouble, that there is the more levels of inheriting, that there are the children and inherits properties in the JSON. So I'm just thinking that maybe those overs could, yeah, let's focus on, yeah, that one, that you have to write at the very beginning what are the children of your entity. And if we truly think about, you know, mixing data from different sources, then maybe you don't know what the children will be added from different parties. So yeah, maybe that children can be set with some kind of an over that, you know, other party will just plug and play more children into our host object. That's my idea, and it will also make that those children will be not as a property of those JSON objects, but they will be a separate entity when the parent and child relationship will be provided, because now it's just that, yeah, it sits as a property, is the array of those children, and that's why it is. So maybe that will evolve, but yeah, I'm not working on that, just to have, you know, clear way. It's just my some assumption, which I think that it will open new possibilities. But okay, and the last part, which I am a little worried how I have done it, because yeah, it's the place when we are trying to flatten the classes, and only the classes, because we want to display the devs, so that MySpace, which is not marked as a dev, but it is there, and so that class, that identifier, it is not available from the viewer itself. Its properties, its body, its void, its boundary wall, they are there, but they are the devs. Devs are things which reside in the space. They are there. So you want to get their properties, we want to construct them, but unfortunately, they are the result of inheriting from some classes. So that's how that reader is working, that it just tries to, okay, we are getting the classes and attaching their properties into the parent devs. That's what that class is doing, and I'm not very proud of that for each loop, because yeah, in terms of higher trees, it could lead to some stack overflows, but yeah, we are not dealing with big IFC5 files, but yeah, let's just think that now we have such a tree, and for the human it's quite a big one. For the machine, of course, it's no brainer, but if we imagine the whole project in terms of the tree and how many levels it will have, yeah, we will see how the IFC5 development will evolve. But yeah, I think that that's all what I wanted to say. I strongly recommend that repository. It has a lot of data, but of course, without the curse, you will be a little blind. So just enroll. I think that it is still for everyone. I just found it somewhere on LinkedIn. So yeah, that's how I have joined into that train, and I'm really happy because, yeah, usually we are just, you know, here is the new format. Let's face it. But now there is the place when we can raise our concerns, when we can try and think, okay, maybe that thing would be a little done a little differently. And of course, it will make the whole process of development much harder, because there will be many voices, many actors which will just try to pull the rope onto their side. But, you know, I really like the idea to make the development open and clearly visible to anyone who wants to see the details. So, yeah. Please visit that repo. Let's go. I have to finish that course, and of course you can always play around with that .NET sample for the reader and importing into the Rhino. So that's all for today. Thanks, and see you next time.